Good morning. First of all, I don't know if you checked your email, but I sent you a message, everybody a message yesterday. These two items, I had those two signs in red wrong yesterday, and as soon as class is over, it whacked me right between the eyes. The way I remembered is this. I'll just go through this again, and maybe we can start off the class by doing some of the examples from the assignment. But once again, if you have the sum of two cubes or the difference of two cubes, this technique works. Take the cube root of the first term, take the cube root of the second term, mimic the signs. That was all correct. And I said, take this guy and square it, put it over here. Take this guy, square it, put it over here. Take the product of the two, a times b, and make that your middle term. And this sign should always be the opposite of this one. That's what I should have told you yesterday. So if this was mimicked from here, and this guy is always the opposite of this. Like what? Cube root of this guy, cube root of this guy. Mimic the sign. Take this guy, this guy and square him, put him here. This guy and square him, put him here. Take the product of the two, x, y, and then this sign is the opposite of that guy. There we go. Now we got it. Sorry about that mistake last time. So I'll tell you what, let's just do a couple from the P-4 assignment. Yeah, I got to locate them now. Okay, 39 is one of them. You've got x cubed minus 8. Is that the sum or difference of two cubes? Yeah, 8's a perfect cube, and so is x cubed. Is that obviously that's a minus sign. So, set up a binomial and a trinomial. Take the cube root of the first term and put it here. Take the cube root of the second term and put it here. Mimic the sign, minus. Now, take this first guy and square him, put him in the beginning of the trinomial. Take this guy and square him and put him at the end. And by the way, that's all. But when you square a term, won't that last term of that trinomial always be positive? Because doesn't squaring always generate a positive? Okay, then take the product of the two. 2 times x is 2x. And then make this sign right here the opposite of that one. Now, something unique about this is that that trinomial looks spookily close to being a ding-ding-dinger translation. It looks really close to being a perfect square trinomial, doesn't it? Yeah, I'm kind of a ding-dong. But anyway, what's wrong? Why is that not a perfect square trinomial? The first and the last terms are perfect squares, but the middle term has to be what? Remember how that works? To be a perfect square trinomial, you take the root of that, that's x and 2, multiply with 2x and double it. And that middle term is just not high enough. Otherwise, it almost looks like we have a perfect square, but you don't. So that's it. What's another one? 40, I'm trying to think of another one you guys had to do, like y cubed plus 64. Is that the sum or difference of two cubes? Yes, 64 is a perfect cube. It's 4 cubed. So, binomial, trinomial, cube root of y cubed goes here. Cube root of 64 goes here. Mimic sign. Now for the trinomial, take the y guy and square him, put him in the beginning. Take the 4 guy and square him, put him at the end. And for the middle term, take the product of the two. 4 times y is 4y. And for the sine, the opposite of that guy. I don't know, maybe we'll just do one more. Let's see, is there anything a little bit? Maybe 45 is a good one. We've got u cubed plus 27v cubed. Is that the sum or difference of two cubes? It is. So binomial, trinomial. Okay, cube root of u cubed. Cube root of 27v cubed.